Good morning. So today I'd like to talk about an approach to ellipsis that tries to combine the best features of the PF-Deletion, LF copying, and Proform theories. We've seen that uh, each of these theories has some advantages and also some disadvantages. And what the theory I'm going to present to you today does is it tries to just take the advantages of each and put them together. So we've seen this empirical generalization that voice mismatches in verb phrase ellipsis are good, while those in sluicing are not. And we've talked about possible explanations for this. The one that Jason Merchant proposed, which goes towards motivating a syntactic identity account of ellipsis, is that there's just one mechanism, and ellipsis, which is sensitive to syntactic structure. And if it happens after you choose the voice of the sentence, then that's called sluicing. And of course, then, because it's sensitive to syntactic structure, the voice has been chosen and you can't vary it. And if it is performed, if ellipsis is performed before you've chosen the voice for the sentence, that's verb phrase ellipsis. And because you haven't chosen the voice of the sentence, it doesn't matter what the antecedent is. You can then pick a different voice than you did in the antecedent clause. But of course, as we discussed already, this timing perspective on ellipsis accounts for a different generalization. And that generalization is that mismatches are a root phenomenon, a root-like phenomenon, in the sense that the mismatch should only be allowed of the voice in the clause in which you're doing the verb phrase ellipsis, but that if you have other voices in that ellipsis site, they can't be varied. Okay, that's what this sort of syntactic identity, timing-based syntactic identity account predicts. And it seems that this is a good prediction. Okay, the example that we've seen already, this information seems to have been released, although Gorbachev doesn't. That sentence really is a fine sentence, but it only has the meaning that Gorbachev doesn't seem to have been released. It doesn't mean that Gorbachev doesn't seem to have released this information. Okay? And we can contrast that with the similar sentence that Daniel Hart gave in his dissertation. This information could have been released, although Gorbachev chose not to, which is then just monoclausal. Okay. So, the slide's title says that this is bad, and so we must wonder why. And the reason that it's bad is that there are really good reasons to say that ellipsis is not sensitive to the syntax. So we have all sorts of structural mismatches that Daniel Hart cataloged for us, and others, right? It's not just verb phrase ellipsis. Oh, I'm sorry, it's not just voice. There's all sorts of things. There's vehicle change, which is something that we haven't discussed yet, but which essentially amounts to the observation that proper names in the antecedent can behave as though they were not proper names in the ellipsis site. So an example of that is Mary loves John, and he thinks that Sally does too. Okay? So this sentence is a fine sentence. But if we were to spell it out, we would get the sentence, Mary loves John, and he thinks that Sally loves John too. Okay? And this is not an okay sentence if he is supposed to be John. Right? it runs afoul of the binding conditions, principle C. Okay, John is bound by, or is C commanded by a co-indexed pronoun. He thinks that Sally loves John, which is, problematic. Right? Or that configuration is problematic, which explains why Mary loves John and he thinks that Sally loves John too. Doesn't sound right if he is supposed to be John. But if we do verb phrase ellipsis, it's fine. Mary loves John and he thinks that Sally does too. Okay. So that's vehicle change. There's island amelioration effects in ellipsis. And what that means is that, in particular in sluicing, and what that means is that configurations that in normal syntax would block movement, they would be islands for movement, in ellipsis sometimes seem as though they don't block movement. Okay? So that makes it seem as though ellipsis is not sensitive to syntax in that sense. There's code switching, which we'll talk about towards the end of this talk here. And the list just goes on. There's a lot of reasons to say that ellipsis is not sensitive to syntax. Okay? And so the resolution of this paradox, the way we navigate between the Charybdis and the Scylla of who's right and who's wrong, of being sensitive to syntactic structure and not being sensitive to syntactic structure, is just to say that everyone is right. Okay? It's just that there are different notions of structure that they're right about. So ellipsis has to be sensitive to syntactic structure 1, right, subscript 1, but can't be sensitive to syntactic structure subscript 2. Okay? That's going to be the strategy that I pursue here. And of course, that doesn't mean anything, right? Or rather, it's not clear that it means anything. So I'm going to have to tell you what syntactic structure subscript 1 and syntactic structure subscript 2 actually are. Okay. So the overview is that we're going to take the LF copying approach, but copy meanings instead. Okay. And what we're going to do is shift our perspective from LF to the derivation itself. Okay, so I'm going to then talk about what derivations are, and then I'm going to talk about what ellipsis is like in here. Okay, and the ultimate goal is to have a theory of ellipsis that that helps us understand what's going on, but I'd like it to be computationally tractable. Right? That's sort of the goal. Okay, so we're going to talk about derivations. Okay, and derivations are recipes. That's just what they are. There's a chocolate chip cookie recipe on the slides. I haven't tried it out, but that's what a recipe is, and that's what I'm saying derivations are. Okay, so the lexical items are the ingredients, and instead of the complicated actions that we might perform in a normal kitchen recipe, like bake, broil, whip, we just have our grammatical operations, merge and maybe move. Okay? Depending on your syntactic theory, you might have different operations. Right? If you're a tree adjoining grammarian, you might have substitute and adjoin. Right? If you're a combinatory categorical grammarian, you might have a few more. Right? But whatever your grammatical theory is, the operations that your grammatical theory gives you are what you're going to do instead of baking, broiling, and whipping. Now, one important property of derivations that we often don't notice is that derivations are structured. Okay, and they're structured in a very rich way, and this is true of recipes in general, right? Because derivations are recipes. Recipes are structured, and they're structured in that some things have to happen before other things happen, right? And at other times it doesn't matter. So, for example, if you want to combine sugar, butter, and flour, one way to combine the sugar and the butter is to cream them together. And that's, mixing beating the sugar and the butter together until they become this nice, delicious, gooey substance. Okay. If you add flour before you do that, you're never going to be able to get that substance again. Right? That substance can only happen if you put the sugar and the butter together first. Okay. Likewise, when we derive, say, sentences or verb phrases, what we want to combine a determiner, a noun, and a verb, just like we wanted to combine the sugar, the butter, and the flour. But we have to do it in a particular order. We have to put the determiner and the noun together before we add the verb. So most of the time, I hardly ever see derivations written down in syntax papers. But when you do, you often get them in this list-like linear way. And I want to present them in a different way, which highlights the structure that they have. Okay? So I'm just going to show you a derivation as a list on the left-hand side and as a tree on the right-hand side. Okay? So we're going to first start out by taking every out of the lexicon. Okay? And then the next thing we do is we're going to take boy out of the lexicon. Now, technically, we could have ordered this in any way. Right? We didn't have to first choose every and then choose boy. We could have first chosen boy and then chosen every. But if we write a list down, we're forced to decide which thing happened before which other thing. Okay. The next thing that we're going to do is we're going to merge the every and the boy that we selected to get the DP every boy. Okay. Notice that the thing we get is independent or is different from the step that we did to get it. Okay. As the result of creaming the sugar and the butter, this creamy, gooey, sweet, buttery sugar substance, is different from the step of creaming the butter and the sugar. Right. So we merge every and boy. On the tree representation, I just indicate that by writing the word merge and connecting it to every and to boy. Next, I'm going to select laugh. And then I'm going to merge laugh and the DP every boy. Okay? And that's going to give me the VP laugh with every boy attached to it. Okay? In the tree representation, I'm just, again, writing what we're doing, merge, and connecting it to the things that we're going to merge. That didn't merge them. It's just writing what we're going to do and having lines pointing to who we're going to do it to. Okay? This structure on the right is not the tree that we're building by doing a derivation. It's just a description of the derivation itself. Okay? Just like the list of steps on the left is not the tree that we're building, it's just a description of how to build it. Okay? Just like a recipe for cookies is not cookies, it's just a description of how to build cookies. Okay? Next, we're going to select will, and then we're going to merge will and the VP laugh every boy. Okay? Finally, we're going to move every boy from its position next to laugh up to the specifier of IP, up to a position above will. Okay? And in this tree representation, which is not a tree but a directed graph, I'm writing move, which is what we're going to do. And on the one hand, I'm pointing to the thing, the landing position, or I'm pointing to the entire expression that we're going to be doing move on. And on the other hand, I'm pointing to the thing inside of that expression that's going to be moved, the every boy. Okay? All right. So on the left, we have a list of steps. On the right, we have a tree-like structure. Both the list of steps and the tree-like structure are describing the same thing. They're describing a derivation, or they are a derivation. They're just representing that derivation in a slightly different way. On the left, we have represented a derivation as a list of steps, and on the right, we've represented the derivation as a tree-like object. Okay? The information, the crucial information about derivations, that some things have to happen before other things, is encoded in the list by means of linear order, right? If you happen before something else, then you're written earlier in the list than that other thing is. In the tree, if you happen before something else, then you are written underneath that other thing. Okay? So, for example, step 5 and step 3, step 3 had to happen before step 5. Step 3 is building the DP, and step 5 is building the VP. And in the tree, what corresponds to step 3, which is the node labeled merge immediately dominating every in boy, is underneath, or is contained in, the part representing the step 5, which is the merger of laugh and that DP. Okay? So linear order in the list represents what has to happen before what other things in real derivations, and embedding in the tree represents what has to happen before which other things in derivations. Okay? But that same information that I said was crucial is being represented in both the list and the tree notation. Of course, the list notation forces you to decide that everything matters. Right? So one of the things that I said about the structure of derivations is that even though order was important, sometimes it doesn't matter. In this list representation, it always matters. Right? We don't have a choice. We have to say for everything, it's at a different position in the list, and so it's either before or after every other thing. Whereas in the tree, we can have parts of the tree that are neither contained in, that are not contained in the other, or do not contain the other. Right? So for example, laugh and the merge node dominating every int boy, neither does laugh contain the merge every boy, nor does merge every boy contain laugh. They're independent. They're sisters. Okay? So this tree representation doesn't force us to say that order matters always. All right. So now that we've seen this representation for derivations, I want to talk about structure in minimalism. What are the things that the derivation, or that we build when we do derivations? Okay. Here's a kind of example. Here's an example of what some people might say the structure of the sentence "every boy will laugh" is. So here I've availed myself of the copy theory of movement. So every boy, because it was internally merged, appears twice in this structure. I've also used bare phrase structure, so nodes are labeled by lexical items, and that indicates the projection relationship. So an internal node labeled by a lexical item is a projection of the leaf that has that lexical item, that is that lexical item. Okay. Now, this is not quite right because the occurrences of every boy are supposed to be non-distinct. Okay? Now, it's not quite clear what non-distinctness is supposed to mean. Um, sort of an annoying phrase. One way to think about non-distinctness is that it's indicated by co-indexation. Okay? So every node in the tree has an index, but sometimes you might have the same index, and in that case, you're non-distinct. Okay? This is deeply problematic. But of course, the easiest way to understand non-distinctness is to treat non-distinct as meaning the same thing as the same, right? Which it sort of does in common parlance, right? So, yeah, the occurrences of every boy are non-distinct. Why is that? Because it's the same. There's just one every boy, and it just is in two places at once. Okay? And this is sometimes what people call move as remerge. Okay? And a lot of people don't like this, although I've never really understood why. It seems to me to be the obvious and right way of implementing this idea of the copy theory of movement. Yeah. Anyways, so this, I would say, is what structure in minimalism is. I mean, we can go back and forth. Do we want to have this version of the copy theory of movement with distinct but officially non-distinct copies, or do we want to have the multiple dominance theory with just one thing? I don't really care, but I'm going to be looking at the multiple dominance theory. I'm going to use this multiple dominance representation as what counts as structures. My example of the thing we're building up when we build sentences. Okay. But if you really, really, really liked this representation, you could think about that too. Okay. So the reason why I wanted to do that, I wanted to talk about what we're building when we derive structure, is because I wanted to contrast or compare and contrast the thing we just built, this thing on the right, this multiple dominated sentence, every boy will laugh, the derived structure on the right, with the structure of the derivation on the left. Okay? Those are different things. Those are supposed to be different things. The structure on the left is a description of the derivation. It's a description of the recipe that tells us how to construct the thing on the right. Okay? But let's think about this a bit. Nowadays, people believe in, let me just call it anti-symmetry. They believe that the order is not meaningful. The order that you draw trees in is not meaningful. They want to have trees basically be unordered and to have a separate step of linearization. Okay? And so if we reorder this tree on the right, just so putting every boy, that constituent, underneath laugh, okay, we just reorder that, well, then we see that suddenly the thing on the right and the thing on the left are copies of each other. The only difference is how we've decided to label the internal nodes. Okay. Now, I think this is very significant. To me, this tells me that the derivation itself is the structure that people want to assign to sentences. The derivation itself, because the derivation already is structured, we can view the derivation as a structured object. We don't need to have essentially the derivation copy itself or reify itself. Right? All of the structure we want to assign to sentences is already implicitly present in the derivation itself. And so if I were to be provocative, I would say that we've been writing derivation trees all along, we just didn't realize it. Okay. Now let me just say three, since there are three things there, two properties of structure that people like to talk about are automatically true of derivation trees. So no tampering is something that Chomsky proposed once, the no tampering condition, and that says once you build a structure, you can't go back and change something inside of it. You can't change it once you've built it. Okay? And of course, a derivation, a recipe, the step-by-step description of how to build something, you can't go back and change a step retroactively, right? That doesn't even make sense. You just change the derivation then. Okay? Extension, the extension condition says when you build structure, you add things to the top. Okay? And of course, that's true of derivations for much the same reason as the tampering condition is true of derivations. The derivations is just a description of how to build something, and you say, okay, first you do this, and then you do this, and then you do this, right? And if you draw that as a tree, you're just adding things to the top. First do this, and then you do this to that, which means you write a new node describing what you're going to do, and you connect it to the thing immediately below it, so on and so forth. Okay, so no tampering and extension are automatically true of derivations. Finally, numerations. There's this strange idea floating around in minimalism that we want to assign some sort of reality to some sort of utility to specifying the lexical items that you're going to use in a sentence. And people reify this and say you take a numeration, or you grab a bunch of lexical items and get ready to use them. Well, of course, a derivation tree, the lexical items you used are just the leaves of the tree. Right? So if you want to state a condition on numerations, you can just say, okay, we're going to talk about the leaves of this tree. So everything we want to do with structure is already present in the derivation tree itself. Okay. And so I'm going to suggest forget derived structure. We just want the derivation tree. Okay. So this, I think, I would like to say that this is what we've been doing all along. But of course, this isn't how we've been thinking about what we've been doing all along. So I think this is it's a perspective shift. It's not saying that I'm not going to be doing anything differently. I'm just going to be talking about it differently. Okay? So I want to say that we've been looking at the right structure. We've just been thinking about it in the wrong way. So the crucial difference about derivations and derived structures is this non-tampering condition, this extension condition. Because if you really hold on to that, then what it means is if you don't like the structure you have, then you just have to build it differently. Okay? So this rules out things like structure removal or certain ways of thinking about late adjunction and the like. Okay? Now, this is a perspective on structure that has been around for a long time. Unfortunately, not in sort of the Chomsky linguistic tradition, but in categorical grammar, this is what people have been saying from the get-go. Mark Steedman has a nice quote, I think. I think it's nice. I know it's from Mark Steedman. And according to this quote says that syntactic structure is nothing more than the trace of the algorithm which delivers the interpretation. Okay? Which means it's not something that you have to build, so to speak. It's just a description of the steps that the sentence processor took. I think that's a nice way to think about structure. So here's our structure. This is the structure that we're using. Okay. If we replace the node names with lexical items, then we exactly have the multiple dominance or the remerge approach to copying for the sentence. Every boy will laugh. Okay, but I'm going to keep move and merge there. Now, movement is as we see here in this structure, is the operation that takes us from a tree to something more complicated. But of course, movement has been a central focus of Chomsky linguistics since, it's not true since the get-go, but for a long, long time. Okay? And over the years, we've formulated, in minimalism now, a lot of constraints on how exactly movement should work. Okay? And 3 of these constraints are written on the right. There's attract closest, there's minimal link, there's shortest move. I didn't define them because I just wanted to point out the property that they all share, which is that they are stated in a superlative form. Okay, the closest thing, the shortest move, the minimal link. Okay, so those have the linguistic feeling of there being a unique decision. Okay, there's another movement constraint that I like because it's easy to state. It's the SMC, and that says you can only be there can only be one thing moving for a particular reason at any time. Okay, and that really just sort of reifies the uniqueness sort of implicit in the names of these other constraints. So if we adopt this, then we don't need to draw the line from merge pointing to the thing that's going to, from move pointing to the thing that's going to move, because we can figure it out without being told. It's the closest thing, or the one that will have the shortest move, or the one that would engender the minimal link. Okay? So I'm just going to leave it off. We're going to leave it implicit, and then we're going to have to figure out who's going to be the mover. But that's okay, because the derivation just needs to give us enough information so that we can carry out the steps to build the structure that it's talking about, to build the sentence that it's talking about. Okay? Just like in a cookbook, in a recipe, you know, the recipe writer, the chef, is not going to tell you all the details about everything. He's not going to say, whisk the cream at this speed with this hand angle for exactly this many minutes. He's going to say, no, whip the cream, take your time, go as fast or as slow as you want. He's not even going to say that. He's going to say, whip the cream until it's achieved the desired consistency. Right? And the better you get at cooking, the more targeted the recipes are at the advanced group, the less information there's going to be. Okay? But that's okay, because we can figure it out. So, for the last thing I want to say about structure before we go back to ellipsis, is one thing that people like to say about structure and minimalism is that structure building is really just set formation. Right? Merge of two things is just forming a set of those two things. Okay? If you thought that that was an important idea, I don't, but if you did, then we could represent this derivation on the left via the sets as on the right. We could have that the merger of two things would be represented by the set containing them, and then we could have that the movement, the saying next we want to do move, we could represent that as just the set containing that thing, which happens to be the same as that thing merged with itself. Okay, this is not important, I think, because I think the entire goal of representing structures as sets is sort of bonkers to begin with. But if you really thought that was important, you could do it. And then this set theoretic object down here on the bottom right represents the derivation on the left. Okay? I say it represents the derivation on the left because that set theoretic object is telling us no more and no less than that derivation on the left is. Right? It's really just another way of writing down derivations. We have lists, we have these trees, and now we have sets. Who cares? Okay, back to ellipsis. I'm sorry, I got caught up in my distaste for this set idea. The important thing to have taken away from this is that derivations are structured objects. We're going to be talking about derivations from now on. Okay, so 3 basic ideas about how to analyze ellipsis. The one, ellipsis is just like a pronoun. John will kiss Mary. John will kiss Mary, but Bill won't. Silent pronoun. The second is that ellipsis involves deletion. So that same sentence, John will kiss Mary, but Bill won't, has the structure, John will kiss Mary, but Bill won't kiss Mary. We just didn't pronounce that last kiss Mary. Finally, there's the ellipsis as copying. So the sentence actually has 2 structures. It starts out looking like a proform, right, and then ends up looking like the deletion account. Okay. So, people have argued that the proform theory is wrong and the deletion or the copying theories must instead be right because you can extract out of ellipsis sites, You can move out of an ellipsis site, but you can't move out of an overt pronoun, of course. So I know which book John bought, but not which ones Bill did. Right? So the way that the Chomskyan style syntax works, it's just not really compatible with this proform account. Okay, but there are other arguments for having structure in ellipsis sites. So one is Ross's case matching effects. So what's happening here is that in sluicing, so it works better in German than in English because we don't have such robust cases. Will jemanden loben, aber ich weiß nicht wen. It has to be wen, it can't be wem. But will jemandem schmeicheln, aber ich weiß nicht wem. That has to be wem, not wen. Okay, so we have, and if how are we going to account for this, right? So on the one hand, ich weiß nicht wen is a fine sentence. On the other hand, ich weiß nicht wem is a fine sentence. But you have to be careful. You can't, if you're going to use the ich weiß nicht, if you're going to say hat jemanden gelobt, you have to use the ich weiß nicht wen version. You can't use the ich weiß nicht wem version. How are we going to account for that? Well, it's very easy to account for if the syntax is there, right? Because then the WH phrase gets its case assigned to it in just the normal way, and that case will be the right case because the right verb is in the ellipsis site, it's just not being pronounced. Okay. There are also preposition stranding effects. Right? So you can't p-strand something with an implicit correlate. This is Chung's observation. There's no p-stranding with sprouting. Okay? And also Merchant's generalization, which is a little problematic, but it's mostly right. If you allow p-stranding in general without ellipsis, then you also allow p-stranding in ellipsis, and vice versa. If you allow p-stranding in ellipsis, then you also allow p-stranding in general. Okay. And finally, voice mismatches across ellipsis types. So Jason Merchant's observation that sluicing doesn't allow for voice mismatches. Right? That's easy to account for if we have syntactic structure in the ellipsis site. It's difficult, it's not obvious how to account for it if we don't. Okay? So these seem like reasons, good reasons, for saying that we need to have syntax in our ellipsis sets. The first one, this extraction idea, seems to me less an empirical argument and more just a simple fact about how the transformational approach to analyses just isn't compatible with um, the program account. So and what I mean there is, if we had a different syntactic theory that didn't use movement, then that wouldn't be a problem. Right? But these other three arguments would still be problems. Okay? So I'm going to present to you now a unified theory of ellipsis, which is a proform theory, which was derived from a copying theory, which itself was derived from a deletion theory. Okay? So it's a proform theory, importantly, but it's going to have a contrast, high versus low, for voice mismatches. It's going to ban stranding in sprouting, preposition stranding in sprouting, and it's also going to capture something like the preposition stranding generalization. It's going to be able to account, and we could also account for case mismatches. So essentially I'm going to present to you a proform theory that is able to account for all of these arguments for syntax and ellipsis sites. There won't be a syntax in the ellipsis site, but still we'll be able to account for these things. Okay. Before I do that, I want to point out to you something that you already know, and that everyone knows. Constituents don't cut it. So in the sentence, Mary was kissed and Susan was too, there's a verb phrase missing. Right? What is that verb phrase? Well, it's kissed, right? Kissed isn't a verb phrase. Kissed is a verb, right? The verb phrase that we built up was, on the one hand, kiss Mary on the left, and on the other, kiss Susan on the right. So if we were to write these sentences using the copy theory of movement, what's missing on the right looks sort of like kiss Susan. Okay? But of course, kiss Susan is different from kiss Mary. Okay? So what we want to do, of course, is we want to not count things that were moved out of the ellipsis site. Okay? That's what we want to do. If something was moved out of the ellipsis site, we don't want to count it. So how do we do that? Well, we just don't count it. Right? Well, I'm going to say we want to count the blue things and not the red ones. Right? The blue things are the things that we're counting. Now, those blue things aren't constituents. Right? They're something else. So there could be different kinds of antecedents. Some antecedents are going to be constituents, and a constituent is what you get if you have a structure and you pick one node, and that's going to be the top of your constituent. Okay? So here we've picked the merge node right above laugh. That's the node we picked, and the constituent that it determines is everything that it dominates. Okay? But we're also going to have constituents that are missing pieces. Right? These are called contexts. So here we pick two nodes. The first one is just like a constituent. That's where we start counting. And the second one is where we stop counting. So here we picked the merge node above will. And as a constituent, that would collect everything that it dominated. But then we picked, as a second node, the merge node above every, and that's where we stop looking at this expression. So that is a context. And of course, that kind of thing is exactly what we have in these simple sentences, Mary was kissed and Susan was too. The context, we pick the merge node above the passive verb, above the passive little v, and we stop at the DP. That context is identical in both sentences here. Okay. So I'm saying that we want a theory of PF deletion that isn't just deleting constituents, but also is able to delete contexts. Okay? We actually need it to be able to delete even richer things, but this is all we're going to talk about today. Okay, and the reason we want to do that again is because that's what we have to say to be able to derive passive-passive ellipsis. Okay, and everyone has to do this, and people just do this in different ways. But if you're going to have a copy theory of movement, then you're forced to exactly this position. Okay. So now, we have a PF deletion approach to ellipses. But I want to adopt a particular perspective on how the grammar is related to the parser. And this is the strong competence hypothesis that Joan Bresnan and Ron Kaplan proposed. And this, according to this strong competence hypothesis, there's a direct correspondence between the rules of grammar and the operations that the human sentence processor performs. Okay? So let's talk about top-down parsing. Top-down parsing is predictive. It's making predictions about what you're going to do. It's connected, which means it's always building a connected structure. And there, underneath these words, predictive and connected, there are quotes, which are just the names of certain papers that I think are relevant here. So anticipatory processes and sentence processing is a paper that talks about essentially predictions that we're making. It talks about ways in which it looks like the human sentence processing mechanism is predictive, is anticipating stuff. The interaction with context during human sentence processing is a paper that's talking about how the human sentence processor is using context to help guide its decisions. And it's able to do that because it's assembling a structure that it can interpret, and then it knows, so to speak, how the context, the semantic context that the sentence is being uttered in, should influence what's coming next. Okay, so the way top-down parsing works is you derive predictions, and if your prediction is that you're going to see, you're predicting you're going to see certain nodes. If your prediction is you're going to see a non-terminal node, an internal node, then you derive new predictions by inverting your rules of grammar if you have a context-free like grammar. So something like VPs are built by taking a V and following them by noun phrases. You would invert that. You'd say, okay, I have a prediction for a VP. Aha, so I'm going to revise my prediction. I'm going to say this VP is going to be the result of combining a V with a noun phrase. So now I have two more predictions, but they're of smaller things. Okay. If my prediction is that I'm going to hear a certain word, then what the parser does is it listens to see if that prediction was actually is true. Okay, that's how a top-down parser works, roughly. Okay, we're not going to be doing top-down parsing, but I mention this because I want us to think about what a top-down parser would do if it were parsing sentences that had deletion, and this deletion was done grammatically by PF-deletion. I'm sorry, processing sentences involving ellipsis, where ellipsis was carried out by a mechanism of PF-deletion. Okay, so the grammar says delete something if it's identical to something else. Okay, that's the PF-deletion idea. So what is the parser going to do? Well, it's not going to delete anything, right? That's not what it's supposed to do. It's supposed to guess what was deleted, right? But it has a hint. It's something you've seen already, right? The parser has to guess what was deleted because it's sort of working backwards, right? When you produce a sentence, you have the structure and then you can delete it, but the parser needs to recover the structure from the words. So it needs to guess what you deleted, okay? But you only delete something if it was identical to something else. And so that's telling the parser, look, you need to guess what was deleted, but know this, it is identical to something else. I.e., hint, it's something you've seen. So if that's what the parser needs to do, then what is it actually going to do? It's going to guess what was deleted, but it knows that that thing that was deleted is something that it's seen. So basically, it's just going to look around at the things it's seen and pick one of them as the structure that was deleted, which is just another way of saying copy something. Okay? So the PF-deletion theory on the grammar would need to be realized in a parser as a copying theory. Okay? So this is what I mean by saying we have a LF copy theory derived from a PF-deletion theory, right? Because copying is just how you would implement deletion in a parser. Okay, so the point of what we're doing here is to look at a proform theory and make it sensitive to syntax in some way, okay? But let's first look at these parts of derivations that we are either copying or deleting, okay? So here's an example. This part here, it's in blue, it's highlighted in blue. But notice that I've added some information to it, right? I've added an arrow coming out of it saying it makes a little VP, because it does, right? If you fed this chunk of a derivation a DP, which it's missing right now, if you were to feed it a DP, it would do its thing and produce a VP, okay? So this kind of information, what it needs and what it will produce, is different from information about how it produces that, what it will do. So the blue shaded things are described steps that our grammar will be carrying out, describes steps of the derivation, okay? That's what I'm calling its internal structure. Right? And it's basically saying, how do I do what I do? The external structure, which we might call categorical or distributional information, is what do I produce and what do I need? Okay? So there's a picture of a jigsaw puzzle without a picture on it. And that's because the border of the jigsaw puzzle, the border of each piece, is what I'm calling its external syntax. Right? It's describing how it fits into the puzzle. And the internal structure of a jigsaw puzzle piece would be the picture that's on top of it. And notice you don't need the picture. The picture doesn't play any role in putting the puzzle together. I mean, if you don't have a picture, God help you. But the pieces will fit irrespective of the picture on it. Right? You can color over the picture with a red marker and just have a red blob, and it'll still fit in the same place. Okay? So what matters for putting things together is not the picture, it's the boundary of the piece. Likewise, what I'm saying is that what matters for putting pieces of derivations together is not what's inside them. It's not what they do. It's the boundary of that piece. It's what it's missing and what it produces. Okay? So this thing on the left is the structure that we used, that we deleted in our PF-Deletion account of the passive sentence, Mary was praised and Susan was too. Okay? So the processor, what it's going to do is it's going to look in the context for a chunk like this, and it's going to copy that chunk. Okay? But what do I mean by a chunk like this? The processor knows, hey, I'm missing a little VP, and that little VP was itself missing a DP because I've got that DP right here, Susan. So the processor knows the boundary of the ellipsis site. It knows it's missing a DP, and it produces a VP. And what the processor needs to do is to recover what its internal structure was. Okay? But does it have to do that? Not really, because all we really need is its meaning. Right? The processor just needs its meaning. So we can just interpret it. And all the processor needs to do is to look in the discourse for a meaning that was constructed by a syntactic structure that had this kind of boundary. Okay? So as far as the parser is concerned, there is no syntactic structure in the ellipsis site. Right? There's the external structure of the ellipsis site. That's where the ellipsis site fits in. But there's nothing inside the ellipsis site, according to the parser. Okay? Now, let's go back to this strong competence hypothesis. Right? So this is really a meander, which says that there's a direct correspondence between the rules of the grammar and the operations performed by the human sentence processor. And note that I said, as far as the parser is concerned, there is no syntactic structure in the ellipsis site. Right? So this is the syntactic structure of the sentence. Oh, I guess it was Susan was kissed and Mary was too. I don't know. Okay. This was the structure we assigned to the sentence Mary was too, and this blue thing here is just what we deleted, what we didn't pronounce. Okay. But now I'm saying, as far as the parser is concerned, it never bothers building that blue piece. Okay. So that's what the parser did. Okay. This picture here is what the parser essentially did. It just says, yeah, great. Ellipsis site, wonderful. I just need the meaning. I don't need the syntax. But now let's reflect that back into the grammar, because we want there to be a direct correspondence between the rules of the grammar and the operations performed by the human sentence processor. And what we get is, I think this is what we get, is typed ellipsis sites. So we have an ellipsis site, like a proform. It's just a proform. But it's a proform that says, hey, this is my external syntax. This guy here is missing a DP, and when you give him a DP, he'll produce a VP. Okay? So how does he fit into a structure? Well, if you give him a DP like Mary, he'll produce a VP of the kind that can be merged with past tense. Okay? Now, the interpretation of this thing is just as a pronoun. I've written a lambda term there, which doesn't mean anything to you because I haven't talked about it yet. Okay? I'm going to skip this slide. What the heck? It's not like anyone is waiting. So what is the picture that emerges from this? Well, the parser needs to maintain a database of possible elliptical antecedents. And when an ellipsis site is encountered, it has to select an antecedent from this database. Okay? Now, of course, these antecedents are not syntactic structures, they're just meanings. What do we do in the world of pronouns? Well, we need to also maintain a database of possible pronominal antecedents. And when you encounter a pronoun, you have to select an antecedent from this database. Okay? Now, interestingly enough, ellipsis and pronominalization, pronominal anaphora, when we state it like this, they're very, very similar to one another. In fact, they're identical to one another. But there is a difference between them because the selection process by which we pick an antecedent meaning for ellipsis, we care about the external syntax that the structure that gave rise to that meaning had. Whereas with pronouns, we don't care at all about the external syntax, about the syntax, external or otherwise, of the DP that gave rise to that meaning. Okay? So that's the difference between ellipsis and pronouns. Ellipsis cares about the external syntax. Pronouns don't. So here's an example. I'm switching back and forth between Mary and Susan. So the sentence that I said before, Mary was kissed and Susan was 2, or maybe Mary was kissed, period, Susan was 2, because I have 2 separate structures, there's no and. This here are the structures that I would assign to those 2 sentences. Mary was kissed is the structure on the left. I've highlighted this chunk of derivation in blue, not because we're deleting it, but just because it's the part that counts as the antecedent. And the syntactic structure of the sentence, Susan was 2, is on the right. And again, the E is highlighted in blue, not because, it's just highlighted in blue for no reason at all, actually. Now, E is a grammatical operation. What does it do? That grammatical operation, it's like merge or move. It's not a lexical item, it's like merge or move. The intuition behind E as a grammatical operation is, hey, look, we've already built something. Instead of building it again, let's just go back and grab it. So this E is a derivational step that tells you, look, we already built something. I don't want to derive it again, so go grab it. Take it from where we built it and use it again. Okay? So here's how that works. When we interpret the sentence, Susan did 2, we get something like this. Can you see the highlighting when I highlight it like that? You can. That's wonderful. Okay? We get a meaning like the one I've highlighted just now. Okay? Notice that we have this E, this ellipsis operation. We need its meaning. What is its meaning? Well, it's like a pronoun. It says, my meaning is gotten by looking in the in the database of antecedents and picking an appropriate meaning. Okay? What is the meaning that we want? Well, we want the meaning of that blue chunk of derivation. And this blue thing down at the bottom of the screen is the meaning of that blue chunk of derivation. And so E is going to be resolved, like a pronoun, to that meaning. Okay? And everything is going to work out, and it's going to mean Susan was kissed too. Okay, so this idea is not, unfortunately, novel to me. The same idea appears in other traditions. It appears in dynamic syntax. It appears in categorical grammar. The essence of this idea is that derivations are descriptions of computations, and that instead of repeating the same computation that you already did before, you just do it once, and then you share the result of that. Okay? And this idea is also originally from computer science. So in programming language theory, we call it memoization. In the theory of algorithms, we call it dynamic programming. Okay, so that's this idea. That's the idea here. The idea behind ellipsis that I'm offering here is we've already done something. So instead of doing it again, just give the parser instructions. Look, you've already seen this. Go back and get it. Okay. So here are some of the arguments for syntax in ellipsis sense. You can extract out of an ellipsis site, but not of an overpronoun, so on and so forth. Okay. So let's look at some of them. Well, we're going to look at some of them. But all of these arguments only require sensitivity to external structure. None of them require sensitivity to the internal structure. They only require that the meaning that we retrieve for ellipsis be a meaning that is the meaning of a syntactic structure that had the same external structure as our ellipsis site. That's all they end up requiring. So let's look at two of these. So the last two, the voice mismatches across ellipsis types, and the code switching ellipsis generalization, which we haven't talked about yet. We're going to look at both of these, and we're going to see how this approach, this proform approach to ellipsis, is able to deal with it. Okay? So how does this work for verb phrase ellipsis? Well, so we're going to start with small VPE where we want voice mismatches to happen. And then we're going to go on to big VPE where mismatches don't work. Okay? So, here's a voice mismatch. Mary teased John and Susan was too, right? So that sounds awful. But there are sentences in the literature that involve active, passive, or active antecedents and passive ellipsis sites. So one is Max fired Harry, although it was Tom who should have been. Right. So my personal judgment is that active antecedents, passive ellipses, often sound much worse than the passive antecedent active ellipsis. Right. But Max fired Harry, although it was Tom who should have been, isn't an awful sentence. Right? And it's certainly much, much better than this terrible Mary teased John and Susan was too. Right? We should just take this Mary teased John and Susan was too as a short, i.e., something that fits on the screen, proxy for the good examples of this construction. So the thing on the left, marked antecedent, is the syntactic structure of the antecedent. It's the derivation of the antecedent. It's how do we derive the antecedent? So we start out by merging T's and John, then merging a little active head, and then moving John to get case, and then merging Mary, the external argument, and then merging tense, and then moving Mary. That's how we build the sentence Mary teased John. How do we build the sentence Susan was too? Well, its derivation is here on the right. We take Susan, we use an ellipsis operation to convert it to a big VP. Right. Then we merge that big VP with a passive voice head, and then with past tense, and then we move Susan. Okay. Now, this ellipsis site converted a DP into a VP. So that's the external syntax that it's going to be looking for. So it needs to find an antecedent that had that external syntax. Hey, here's one. It's the merge and the T's. Okay? And so all it needs to do is it needs to find that structure and then stick the meaning. Compute its meaning and pop the meaning into that ellipsis site. And then we're done. Okay. Passive active, John was teased, but Susan didn't, or rather the Gorbachev sentence. This information could have been released, but Gorbachev chose not to. Again, the structure for the antecedent is on the left. We merge John and T's. We merge a passive voice head. We merge past tense, and then we move John. The syntactic structure of Susan didn't is as follows. We take an ellipsis operation that from thin air gives us or out of thin air conjures up for us a VP, a big VP, right? Its external syntax is just VP. It doesn't need anything. It already is a VP. We merge it with an active voice head. We add Susan, yada yada yada. Okay, so we need to find a big VP, and in fact, there is one. John T's, or T's John. Okay. Why can't we do that? How do we account for no mismatches in big VPE? So here's with passive antecedent and then an active ellipsis site. And here's the example. This information seems to have been released, although Gorbachev doesn't seem to have released it. Okay? So this is the structure of the antecedent. And to build the verb phrase ellipsis sentence, we need to take Gorbachev and then and then convert it to a little VP with an ellipsis operation. So this ellipsis operation is going to take a DP and convert it to a little VP. So how is that going to happen? Well, where is there a DP? Well, what we want to find in the antecedent is a structure that ends up being a little VP, and we want to take out a DP from there. This is the only one. That's the only one. Okay? There's no other structure that builds a little VP and is missing a DP. Okay? So that means, and what is the meaning of this structure? It is seem to have been released. That's the meaning of this structure. So this sentence, this information seems to have been released, although Gorbachev doesn't. It's grammatical, right? We have an antecedent here. But the only antecedent, the only meaning it can have is Gorbachev doesn't seem to have been released. Okay. Now, code switching in ellipsis. So Jason Merchant has a code switching ellipsis generalization. And this generalization is formulated in the following way by him. All apparently cross-language ellipses involve code switching at the ellipsis site into the language of the antecedent. Okay, so let's look at this paradigm here from González, Vilbaso, and Ramos. Sorry, I don't speak Spanish natively, so I'm not that good. Here we have the Spanish Juan amenazó a alguien, which means John threatened somebody. And this bilingual speaker is code switching, and he code switches into German. Juan amenazó a alguien, aber ich weiß nicht, wem Juan gedroht hat. Okay, that's a fine sentence. I mean, if you pronounce it right. You can also start out with Spanish, Juan amenazó a alguien, and then switch into German, aber ich weiß nicht, wen, and then you switch back to Spanish, Juan amenazó. Okay, so here, the case of wen is appropriate to the case is the case assigned by the Spanish amenazó. Okay, both of these sentences are grammatical. Okay, drohen assigns dative case. Amenazó assigns accusative case. Okay, now, what would happen if we tried to sluice? The only possible sluice here is number 4. Juan amenazó a alguien, aber ich weiß nicht wen. That's the only legitimate sluice. You can't have aber ich weiß nicht wem. Okay, so what that means is, if you were to write out these two sentences, 1 and 2, you're not allowed to delete the TP in 1. So that's what this code switching ellipsis generalization is. In 3 and 4, you have to imagine that the ellipsis site is in the antecedent language. And so in 3, we would have to have code switched Juan amenazó, but amenazó doesn't assign the dative case to the WH phrase, so this would be wrong. In 4, you're forced to code switch into Spanish Juan amenazó, because that's the language of the antecedent, and amenazó does assign accusative case. That's why 4 is okay and 3 is not okay. That's not a mechanism. Maybe that's a mechanism. That's Merchant's observation, his generalization. Jason Merchant and his wife Anastasia Yanakidu have children, and these children are Greek-English bilinguals, and they also code switch. So I believe that Anastasia is the questioner here. She's asking her child, "Are you hungry?" Which in Greek is, I speak less Greek than Spanish, pinas, which means something like, "Do you hunger?" Right? It's a verb. Yeah. Hungerst du, maybe? And the answer is yes, I do. Okay? Yes, I do. So that's, now the problem here, so it's yes, I do instead of yes, I am, right? So we can see that we're not converting into English, right? This isn't yes, I am hungry, right? It's yes, I do. But Jason noticed, hey, neither of, what does it stand for? What is it short for? And it turns out that neither of these potential ways of expanding the answer into non-elliptical sentences are acceptable. So you can't have pinao, which is, I guess, first singular present hunger, right? And you can't have the, I guess, infinitive form of hunger. Right? There's really no way to finish this sentence overtly. Right? The elliptical version is fine, but there's really no, there's nothing there. There's no way to finish it. Okay. So his analysis was to really have very abstract roots and say that the ill-formed examples are in fact grammatical, but they just can't be pronounced for some reason. Okay. So now I want to show you how this data can be accounted for on the approach that I'm presenting here. Okay, remember here's the Spanish data. So let's think about what these, so I'm going to give you an analysis not by actually drawing the derivation trees, but just by reasoning through it with you. Okay, because I'm going to do it in one slide. So, based on sentence 2, it needs to be the case that Vane Juan amenazó is in fact derivable. Our grammar can derive that. Okay? But if that's the case, then Juan amenazó by itself is a piece of derivation that if you give it an accusative DP, it would give you a TP. Right? This occurs in the antecedents of 3 and of 4. Right here, Juan amenazó, and we need to give it this accusative DP. Okay? But there's nothing, no antecedent of type, give me a dative DP and I'll give you a TP. Okay? So, the ellipsis site in 3, that's ungrammatical, the ellipsis site has to be something that takes a dative DP, the Vane, and gives you back a TP. Right? That's what's missing. There's no language, it's just this elliptical operation that takes a DP that's dative and gives you back a TP. Okay? Now in 3, it's going to be looking for an antecedent, but it's not going to find one. There is nothing in 3, in the antecedent, that takes a dative DP and gives you back an accusative, and gives you back a TP. So 3 is out because there's no antecedent of the appropriate kind. 4, however, the elliptical sentence 4 has the structure E dominating vein, and then we're merging a C head and then moving vein to its specifier. But crucially, that ellipsis site, the ellipsis operation, is of the type described in point 2. It's missing an accusative DP, and it would give you a TP. Okay? Now that's fine. And now when we try to, just like 3, that's fine. It's a sort of a grammatical structure. But when we try to resolve the ellipsis in 4, we look in the antecedent for something of type missing an accusative DP, but will produce a TP, and we find something, the Juan amenazó. And so we reuse that meaning. Okay? So this analysis can account for this code-switching ellipsis generalization. It can derive the Spanish data. It can also derive the Greek data. Okay? So it can derive the Greek data if we adopt a particular approach to prodrop. Right? So I have to say something like the sentence pinas, there is a silent pro, a silent pronoun. Okay, this is not obvious that you would want to say that in general. Many people do, but there is no overt pronoun there. But I need to say something like that. Okay. So, what is the structure of yes, I do? Well, it's something like here on the bottom right. You have an I, that's the I, and then you have an ellipsis site that takes a DP and promotes it to a little VP. That's the kind of ellipsis we have. And then we merge our present tense, and then we move I. Okay, we get I do via do support. Okay, but crucially, we have an ellipsis site that's missing a DP and produces a VP. Okay, so what is the antecedent? The antecedent is something like whatever the structure of this Greek sentence is, but we need to assume there's a silent pronoun, which is a DP. We merge that into the structure and eventually produce a little VP, and then we do more stuff. And that is what we're targeting with our elliptical operation. Okay? So the fact that we can't pronounce it, there's no code switched version of that, is fine on this account. All that matters is the type. There's a kind of derivation that took place in the antecedent that we can reuse for the ellipsis site. Okay? And here we go. So the Merchant's generalization was, again, all cross-language ellipses involve code switching into the ellipsis site, involve code switching at the ellipsis site into the language of the antecedent. Okay? So my reformulation here is the following. All ellipses have the categorical properties and meaning of their antecedent. Okay? Why is that a reformulation? Because the way ellipsis works here is that you're reusing the results of the derivation of the antecedent. Its categorical properties are the ones that matter. The derivation. Not a translation or anything like that, but the actual antecedent derivation itself. That's what matters. And its meaning is the one that's reused, not some translation. Okay? All right, so now we can wrap up. The claims that I wanted to make here are that derivations structure expressions. And in fact, they structure expressions in just the right way, in just the way that we want to structure them. And my provocative claim is that we've been using derivational structure all along. Okay. My next claim is that syntax only cares about shape, not pictures. Here I'm thinking about the jigsaw puzzle. I mean, syntax only cares about external information, not internal information. So ellipsis has to be sensitive to external syntactic structure, but it's not sensitive to internal syntactic structure. These are the syntactic structure subscript 1 and subscript 2 from the beginning. Okay? And finally, ellipsis wants a semantic antecedent delimited by its syntactic shape. Okay, the end. There are some more examples of sluicing sentences and VPE sentences and examples about how we can derive them under this approach, but I'm not going to get into that. Okay, you guys can look at it on the slides.